Imagine trying to spend a single day without sticky tape. You seal boxes, wrap gifts, repair torn paper, and even hold important labels in place without giving it a second thought. But here's what nobody tells you. Every roll of tape begins a remarkable journey through chemistry, precision engineering, and massive industrial machines. Today, you're going inside the factory to discover how a simple strip of adhesive becomes one of the world's most useful inventions. Think about this. Every year, manufacturers produce billions of rolls of sticky tape, enough to circle the earth many times if placed end to end. The tape looks thin and simple, yet it combines advanced plastics, powerful adhesives, and incredibly accurate coating technology. What happens next surprised even experienced engineers, because the sticky part isn't actually made first. Before the adhesive ever touches the surface, engineers must create a perfectly smooth plastic film. Even the tiniest scratch can ruin an entire production batch. Inside the factory, huge rollers spin with a deep mechanical hum while sensors constantly watch every millimeter. And this is where the hidden story truly begins. Most people never think about where sticky tape really starts. The journey begins thousands of kilometers away in oil and natural gas fields, where petroleum becomes the raw material for making polypropylene and polyester films. Countries such as Saudi Arabia, the United States, China, and South Korea supply enormous amounts of these petrochemicals to factories around the world. From deep beneath the earth, these resources begin an incredible transformation. Inside petrochemical plants, purified propylene gas reaches more than 99.5% purity before entering polymerization reactors. Under carefully controlled temperatures of around 70 degrees Celsius, tiny molecules join together into long polymer chains that eventually become durable plastic pellets. These pellets may look ordinary, but they form the backbone of every roll of tape you use. The adhesive follows a completely different journey. Manufacturers blend acrylic polymers, natural or synthetic rubber, tackifying resins, stabilizers, and specialized additives to create the perfect balance between instant stickiness and long-term strength. Even changing one ingredient by less than 1% can completely change how the tape performs. That's why every batch undergoes strict laboratory testing before reaching the production floor. Raw materials travel incredible distances before they meet inside one factory. Plastic pellets arrive by rail, tanker trucks, and giant cargo ships, while adhesive ingredients come from chemical suppliers across Europe, Asia, and North America. Every shipment receives careful inspection because even tiny impurities can create bubbles, weak bonding, or uneven coating. One overlooked mistake could waste thousands of meters of tape in minutes. Modern factories also work to reduce their environmental impact. Many recycle edge trims from plastic film production, recover heat from manufacturing equipment, and use solvent recovery systems to capture chemicals before they enter the atmosphere. Every improvement saves energy while reducing waste, proving that efficiency and sustainability can work together. But the most fascinating part of the journey is only about to begin. Now the real transformation begins. Thousands of kilograms of polypropylene pellets flow into giant extrusion machines, where rotating screws spin at nearly 100 revolutions per minute and push the material through heated barrels. The temperature gradually climbs from 180 degrees Celsius to 250 degrees Celsius, 356 degrees Fahrenheit to 482 degrees Fahrenheit, until the solid pellets melt into a thick, glowing liquid. You can hear the deep rumble of the motors while waves of heat radiate from the massive equipment. The molten plastic leaves a precision dye and spreads into an incredibly thin sheet. It immediately passes over polished cooling rollers chilled to around 20 degrees Celsius 68 degrees Fahrenheit, where it solidifies in just a few seconds. The difference in temperature happens so quickly that the film becomes crystal clear and perfectly smooth. Imagine watching a river of glowing plastic suddenly turn into transparent film before your eyes. Next comes stretching, one of the most important steps in the entire process. Powerful rollers pull the film both lengthwise and sideways under carefully controlled tension, making it thinner, stronger, and more stable. Some production lines stretch the material several times its original size before winding it onto enormous master rolls. Most people never realize that the strength of sticky tape comes from this hidden engineering process. Meanwhile, enormous stainless steel mixing tanks prepare the adhesive. High-speed agitators rotate at nearly 500 revolutions per minute, blending acrylic polymers, resins, and additives into a perfectly uniform liquid. The mixture slowly thickens until it reaches the exact viscosity needed for coating. The sweet chemical smell, the gentle swirling motion, and the constant hum of mixers fill the entire production hall. Now comes the moment that gives sticky tape its name. The transparent film moves through an automated coating machine at speeds of nearly 300 meters per minute, while precision rollers spread an ultra-thin layer of adhesive across its surface. The coating thickness measures only a few microns, yet every millimeter must remain perfectly even. One tiny ripple could ruin an entire production roll. Fresh adhesive feels wet, but it still isn't ready. The coated film enters a drying oven stretching dozens of meters long, where carefully controlled hot air reaches around 80 degrees Celsius to 120 degrees Celsius, 176 degrees Fahrenheit to 248 degrees Fahrenheit. As the film moves through the tunnel, moisture or solvent evaporates, leaving behind a perfectly balanced adhesive layer. Warm air rushes through the chamber while giant fans create a powerful roaring sound. After cooling, another protective layer called the release coating or liner treatment ensures the tape won't permanently stick to itself when rolled. This invisible coating allows every layer to peel away smoothly without damaging the adhesive underneath. It's one of those brilliant engineering tricks you never notice until it's missing. The finished material now winds onto gigantic master rolls that can weigh hundreds of kilograms and contain several kilometers of tape. Massive automated winding systems maintain perfect tension from beginning to end. If the tension changes even slightly, wrinkles or air pockets can appear inside the roll. What happens next surprised even experienced engineers because the tape still isn't ready for customers. Gigantic master rolls travel to automated slitting machines equipped with razor-sharp circular blades. The blades spin at extremely high speed, slicing one wide roll into dozens or even hundreds of perfectly sized tape rolls at the same time. The process looks effortless, yet every cut must stay perfectly straight from the first meter to the last. One tiny vibration could affect thousands of finished products. Finally, robotic arms transfer each finished roll to packaging lines, where machines wrap, label, barcode, and seal thousands of products every hour. Conveyor belts move continuously while scanners verify every package before shipment. The factory feels like a perfectly synchronized orchestra of steel, light, motion, and precision. But here's the mystery. How do manufacturers know every single roll will stick exactly as promised? That answer waits inside the quality control laboratory. The journey isn't over when the tape leaves the production line. In fact, this is where some of the toughest tests begin. Every production batch enters a quality control laboratory, where engineers inspect samples before a single roll reaches a customer. Think about this. One tiny defect invisible to your eyes could cause an entire shipment to fail. AI-powered vision systems scan the moving tape at incredible speed. High-resolution cameras inspect every millimeter, searching for bubbles, dust, wrinkles, uneven coating, scratches, and tiny pinholes. These intelligent systems process thousands of images every second, catching flaws that even experienced inspectors might miss. What happens next is a perfect example of humans and machines working together. Engineers then measure the adhesive coating with precision instruments capable of detecting differences measured in microns. The acceptable tolerance may be only a few micrometers across the entire width of the tape. If the coating falls outside specification, the system immediately rejects the roll. Most people never imagine that something so ordinary demands such extraordinary accuracy. Next comes the peel adhesion test. Automated testing machines press the tape onto polished steel plates with carefully controlled pressure before pulling it away at a constant speed. Powerful sensors record exactly how much force it takes to remove the tape. The smooth pulling sound echoes through the laboratory as computers instantly analyze every result. Factories also perform tensile strength tests to measure how much force the plastic backing can survive before breaking. Specialized machines stretch the tape with steadily increasing force while sensors record every fraction of movement. The tape grows tighter and tighter until it finally snaps with a sharp crack. That single sound tells engineers whether the material meets demanding international standards. Even in one of the world's most automated factories, experienced workers still perform inspections by hand. Skilled technicians feel the surface, examine the edges, and unwind sections of tape while searching for tiny imperfections that machines sometimes overlook. Years of experience allow them to recognize subtle problems almost instantly. And this is where human judgment still beats artificial intelligence. Only after passing every inspection does the tape earn approval for shipment. Many manufacturers follow internationally recognized quality systems such as ISO 9001, ensuring every process remains consistent from raw materials to the finished product. In some factories, fewer than 1% of rolls fail final inspection, a remarkable achievement considering millions are produced every year. But here's the bigger surprise. The global story of sticky tape is even more incredible than the factory itself. Now step back and look at the bigger picture. Every year, manufacturers around the world produce billions of rolls of sticky tape, supplying homes, schools, hospitals, factories, and shipping companies in nearly every country. The global adhesive tape market is worth tens of billions of US dollars and continues to grow as e-commerce and manufacturing expand. Imagine millions of packages moving every day. Most depend on a simple strip of tape. China leads global production, followed by the United States, Japan, Germany, and South Korea. Together, these countries manufacture a large share of the world's adhesive tapes using highly automated factories and advanced chemical engineering. Thousands of suppliers support the industry by producing films, adhesives, paper cores, packaging materials, and precision machinery. It's a worldwide network that never truly sleeps. Here's a fact that surprises most people. The adhesive tape industry supports hundreds of thousands of jobs worldwide, from chemical engineers and machine operators to logistics experts and laboratory technicians. Behind every roll stands an entire team of people whose work often goes completely unnoticed. Without them, modern packaging and global trade would slow dramatically.
Did you know some industrial tapes can hold heavy metal panels together without screws or bolts? Others survive intense sunlight, freezing winters, powerful chemicals, and years of outdoor exposure. Engineers continue developing smarter adhesives that are stronger, cleaner, and more environmentally friendly. What seems like ordinary tape is actually one of the most advanced, everyday materials on Earth. Did you know that pressure-sensitive tape became commercially successful nearly a century ago and completely changed the packaging industry? Before modern adhesive tapes, sealing boxes took far more time and effort. Today, advanced acrylic adhesives last longer, stick better, and perform in temperatures that early inventors could only dream about. Innovation never stopped, and it still hasn't. Did you know some industrial tapes can hold heavy metal panels together without screws or bolts? Others survive intense sunlight, freezing winters, powerful chemicals, and years of outdoor exposure. Engineers continue developing smarter adhesives that are stronger, cleaner, and more environmentally friendly. What seems like ordinary tape is actually one of the most advanced, everyday materials on Earth. Did you know researchers are now developing recyclable backing materials, bio-based adhesives, and energy-efficient production lines? Over the next decade, automation, artificial intelligence, and sustainable chemistry could completely transform how sticky tape is made. The factories of the future may produce stronger products while creating far less waste. The journey of innovation is only just beginning. From oil fields deep beneath the earth to giant extrusion lines, precision coating machines, AI-powered inspection systems, and warehouses shipping millions of rolls around the world, you've followed the complete journey of sticky tape. What began as simple raw materials became a product that quietly supports modern life every single day. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.